Good morning, ladies and gentlemen. I just want to let you know that you're in the right place. We are going to do here this online session on concentrated solar power, clean power on demand 24/7, and we're going to begin in 1 minute. So I'd like to welcome you all to use the chat, which is on your right-hand side, to introduce yourself, introduce your company and where you're joining from today. We have a very, very interesting and exciting session today with a lot of really high-level experts. So please let us know who you are and where you're from, because it's very interesting for us to also see it. And we will begin literally in 1 minute. Thank you very much. Well, good morning, good afternoon, ladies and gentlemen, to this online session where we are talking about concentrated solar power. And I have great news for everyone. There is a new report on concentrated solar power out where we talk about how CSP is clean power on demand. And this is the session where we're going to launch it with the people who have created it. So let me tell you a little bit of how this is going today. We're going to have, first of all, a little bit of contextualizing from IRENA and from the World Bank, from Eric Fernstrom and from Dolph, in terms of, why the study, why now. Then we're going to have analysis from the authors of the report, two of the authors, which are Jonathan Sinton and Michael Taylor. And we're also going to have an official from the Tunisia Ministry of Energy speaking about their perspectives for CSP in Tunis. And then also from Gonzalo Marin from the CSP Spanish Association about the perspective of CSP in Spain. So afterwards, don't worry, you're going to have plenty of time to ask your questions. This is going to happen. We're going to have about at least 20 minutes for you to ask any questions that you'd like for our speakers. So before we start, I just wanted to let you know that we are recording this session, okay? So it's going to be available thereafter, and that you can send your questions by the Q&A box at the bottom, and keep introducing yourself by the chat. And first, before we actually start with the presentations, I'm going to ask the speakers to introduce themselves briefly so that you know them if you don't already. So first, I'd like to ask Eric to please, could you unmute your microphone and introduce yourself?
Thank you, Belen, and thanks for having me. I'm Eric Fernstrom. I'm the manager for the energy department for Middle East and North Africa in the World Bank. Thank you.
Thank you very much. Next, I'd like to ask Dolph to please introduce yourself.
Yeah, thank you, Belen. My name is Dolph Gielen. I'm the Director for Innovation and Technology at the International Renewable Energy Agency, and I'm located in Germany.
Thank you very much, Dolph. Next, I'd like to ask Jonathan Sinton to please introduce yourself.
Hi, I'm Jonathan Sinton, Senior Energy Specialist in the Middle East North Africa unit. I'm based in Washington, D.C.
Excellent. Thank you very much. Michael, your turn now, please.
Yes, hi, good morning, good afternoon, everyone. My name is Michael Taylor. I lead the work that the International Renewable Energy Agency does on the costs and performance of renewable energy technologies for Dolph Gielen.
Excellent. Thank you very much, Michael. Belhassan, if I could please, if you can hear me, please, can you introduce yourself? Thank you.
Thank you, Belen. I'm Belhassan Chiboub, General Director of Electricity and Energy Transition, Ministry of Energy and Mines, Tunisia, from Tunisia. Welcome, everybody.
Thank you very much. I'm looking forward to hearing what is going to happen in Tunis. And last but certainly not least, Gonzalo, please, could you introduce yourself?
Hi, Belén, and hello to everybody. My name is Gonzalo Martín, Secretary General at Protermosolar, which is the Spanish CSP Industry Association. It's my pleasure to be here today.
Excellent. So now that you know the speakers a little bit better, if you didn't already, and I can see from all of your welcomes and your hellos that there is a lot of people that are part of the CSP family already there, and that many of these faces are not new to you. You already know them well. I'd like, first of all, let's go into the context of why we're here today. You know, how did we come to put this report together? And I'd like to allow now Eric to please go ahead and then give your opening remarks. Thank you.
Thank you, Belen. And again, it's a great honor to have this seminar, which is a sort of the capstone on a long a piece of analytical work that we have worked with a number of partners with on CSP, but more importantly in looking at and expanding our toolbox of renewable energy options for MENA for the next decade. As many of you know, in the Middle East, North Africa, solar has had a tremendous growth, as in many other parts of the world, 500% increase in the last 3 years, and we expect this trend to continue as larger solar PV projects are being launched, especially in the Gulf. The growth is in fact being so strong that many countries are now hitting limits to how much variable load their system can absorb. And if we want to move on beyond those thresholds, we need to broaden this toolbox. We need demand-responsive renewable energy supply, better planning tool, load forecasting and balancing that works. And we need to strengthen the capacity of regulators and policymakers to properly price ancillary services and balancing services in the grid to really trigger an optimal mix of investments in power generation and the ability to trade electricity and surplus supply across borders. We also need better tools to move demand away from peak and introducing things like time of use tariffs in the region, smart metering, and better load management. In this new phase, CSP can be an important component for many countries in their portfolio of technologies. CSP costs have fallen considerably, as I think most of the attendees know, over the last decades. And we'll soon hear examples of new hybrid configurations, drawing on advances both in storage technology and control systems, enabling a seamless integration of multiple different renewable energy technologies in the same site, bringing down the overall cost of that demand-responsive supply. As I mentioned, we recently included this 3-year program to support countries in MENA to consider the role that CSP could play in their energy mix, in their planning, and in their forecasting. This was called the MENA CSP Knowledge and Innovation Program, or KIP for short, and was funded by the Climate Investment Funds, with contributions also from SMAP, the World Bank Energy Trust Fund. We worked particularly closely with Jordan and Tunisia, two middle-income countries in MENA with very good conditions for renewable energy development. And I'm very pleased that we will hear later from our good friend and partner, Mr. Shibub, from the Tunisia's Energy Ministry. The presentation you'll hear also from the team concerns one of the reports that have come out of this 3-year program. And on this particular report, we worked very closely with IRENA to produce a report that I think is global in scope, but also provides very useful specific lessons for MENA countries that can draw on some of the world's best solar resources. So with that, I just want to emphasize, while the World Bank is not a technology proponent per se, we see CSP and the emerging a confluence of technologies that integrate storage in a demand-responsive renewable energy offer an extremely important part of the future of energy transition. So with that, thank you, Belen. Over to you.
Thank you very much, Eric, for that contextualization of how we come to this report and what is happening right now in the systems as more variable renewable enters. I'd like to ask Dolf now, please, for his opening remarks.
Yeah, thank you, Belen, and hello, everyone. We are delighted with this collaboration between IRENA and the World Bank. It's a concrete example of how we partner with organizations that work on the ground to bring our knowledge into practical applications, very much in line with what we're trying to do. So thanks very much to the World Bank colleagues, to Eric and to Jonathan for this good cooperation, and also thanks to the climate investment funds. So we have been looking at CSP very much from the beginning of IRENA 10 years ago. And we see it really as a key strategic technology in the energy transition, especially in areas which have high direct normal irradiance. So yet its development lags behind other renewable technologies, with around 6 gigawatts installed capacity worldwide, which is around 1% of the solar PV capacity installed worldwide. Now, this new report highlights that with its low-cost thermal energy storage that can provide around-the-clock electricity, that CSP can perform an important role that is different from these variable technologies, because it's a dispatchable form of electricity generation, which will be critical as we increase the share of renewables in power systems going forward. Our global renewable outlook that we issued in April last year identified around 300 gigawatts of CSP needs by 2050 for a 2-degree scenario. In April this year, we will come with a new scenario for net zero, 1.5 degrees. In that scenario, the amount of CSP will increase significantly further. I'm not going to reveal the number now. But so we really see it as a critical part of the total transition, and increasingly so. We hope that this report can help to highlight the value of CSP and its opportunities. And we look forward to the following discussions, how to accelerate the CSP deployment worldwide. So that concludes my opening remarks. I hand back.
Thank you very much, Dolf. Much appreciated. Okay, now I would like to go into the part of where we actually hear from two of the authors of the report. So we go into the meats and bones, if you like. So first, Jonathan, please, if you can prepare your screen and unmute your microphone. We are really very much looking forward to hearing from you and Michael. So can you just make sure that you make that into perfect? Yeah.
Mm-hmm. Great.
Okay, here we go.
Thank you. Thanks, Eric. Thanks, Dolf. And continuing with the thanks, this report would not have seen the light of day without my colleague at the World Bank, now at EIB, Elena Quadros, who really carried this forward over the several years that this report developed. And on the IRENA team, in addition to Michael, Pablo Ralón, I think provided an essential inputs to this at a number of points. An early draft of the report came from our friends at Solar Technical Advisors, Jorge Cervert, Jose Manuel Nieto, and Diego Lopez. And wrapping up, ATA Insights really helped to put the report in the final form that you can download today. In between, there were, I wouldn't say innumerable people who helped, but more than we have time to list here. Please look at the acknowledgements in the report. So onward to our presentation. So as we've heard, CSP, it's an important option for countries that have high direct normal irradiance, combined with thermal energy storage. It is another arrow, or another 2 arrows in the quiver that will help to bring down the overall cost of incorporating variable renewables, inexpensive variable renewables, into energy systems to accelerate the energy transition. Costs are coming down, as Michael's going to describe, through technology improvements, greater economies of scale, and more competitive supply chains. Those supply chains can be localized more than many other technologies, and CSP has so far not encountered any real deal breaker environmental or socioeconomic issues. To date, many of the plants that we've seen around the world have received considerable concessional financing for reducing the risks, reducing investment costs. But as the trend towards IPPs continues, the reliance on public financing is receding somewhat. But at the same time, there's still a role for it in certain places. Perhaps the way forward as well is with technology neutral tenders, and which would allow the combination of CSP and thermal energy storage with other less expensive renewables. We've seen most of the new construction in a few countries, in Chile, China, Morocco, the UAE, but of course there are plants under development in other countries. There's growing interest among some veterans like Spain. We'll hear from Gonzalo on that, and others. DNI is high in quite a few countries. We've heard about sort of stop and start development in Australia, for instance, but Southern Africa, we've seen some development in South Africa, but Botswana just came out with an integrated resource plan. They intend to procure 200 megawatts of CSP. I'm happy to say that that's an effort that the World Bank is assisting in. So there are quite a few spots around the world where we anticipate seeing where countries would benefit from these projects. We've already heard a bit about the different advantages that CSP can bring. This is a summary slide, a summary figure from our book. So a few of the things that we haven't mentioned here is the storage. It's really quite long-lived. The storage is really, thermal storage is really quite efficient. The losses are extremely low, and that's what makes it a good option for sort of longer multi-hour storage, as we'll see later in the presentation. So all of these points we'll get to in the coming slides. Eric summarized well some of the challenges that countries are facing in the face of rising demand for electricity. We have the good news that renewable energy costs, especially variable renewables, are falling. That poses the challenge of incorporating this rising share of renewables. And so that's something that CSP and thermal energy storage can help deal with. Nevertheless, there remains continued strong dependence on fossil fuels. And so anything that can be done economically to reduce that, to have a fully renewable system is quite important. And its energy storage, as Eric indicated, is really the key. But but what kind of energy storage? The attention right now tends to be focused on batteries, but of course there are quite a few options. You know, the most mature of the battery options are lead acid, but lithium ion is coming big into the market, and we have zinc air and flow batteries coming up on as well. But the real big kahuna here is pumped storage. And hydro reservoirs in general. So I think you know, there's a lot of work going on now on how to use hydro reservoirs for incorporating greater amounts of PV, of wind, but a lot of countries don't have that luxury, and those with really good solar resource often don't have water. So the thermal storage with commercially proven molten salts, thermal oil, I think really, you know, this is really where some countries can put their money. There is, of course, no silver bullet regarding energy storage technologies, as with renewables as well. Some like to say silver buckshot. We need a wide portfolio of technologies where there's competition between thermal storage and batteries is really in that window of 2 to 4 hours of storage. Batteries are quite good on the on the order of a few seconds to say up to 2 to 4 hours. But if you're trying to shift generation from the middle of the day, the peak solar PV generation from the middle of the day to the evening, then you're talking about storage of 4 hours and more. And that's where batteries start to get really expensive, and where thermal storage starts to shine. Longer than that, then thermal storage starts to get expensive, and pumped hydro is really useful. You can't get seasonal storage out of thermal storage the way you can with pumped hydro. With that, I'd like to turn to Michael Taylor. We'll talk about costs. Michael, take it away.
All right, thank you very much, Jonathan, and the previous speakers for the introduction. It's my pleasure to be here with you, and I'd like to reiterate Jonathan's thanks to the quite extensive number of contributors to this report that improved it over time and got it to the point where we could release it. And it's a great opportunity to talk again about the role of concentrating solar power and why we think you shouldn't forget about it. You know, there's a lot of talk about the competitiveness of renewables and the variable renewables in particular. So I wanted to go through a little bit of what's been happening in terms of costs and put things in a little bit of context, as Jonathan has already highlighted, relative to its ability to store electricity at low cost and provide dispatchable electricity. So IRENA has had the pleasure of working on the costs and performance of renewables since Jonathan, could you take that back one? I'm not seeming to be able to do that.
Let's do one thing. If you like, Michael, why don't you share the presentation from scratch? It might be easier. Jonathan, if you can take.
Okay.
Let's see if it works then.
Okay, great. I will try to be more careful. So we now have a very large database of project costs. What we're trying to do is provide transparency around the evolution of costs to our over 160 member states and 20 odd countries in Ascension. Here you have a chart. I'll take a moment just to explain this. Each circle is an individual project. The center of that circle is the levelized cost of electricity on the y-axis. From left to right, you have biomass, geothermal, hydro, solar PV, concentrating solar power, offshore wind and onshore wind, with the data for projects commissioned in 2010 and 2019 respectively. The bold line you could see for each of those technologies is the global weighted average in that year. The range that you can see shaded for each technology is the 5th and 95th percentile, and the gray band along the bottom is the new cost of new fossil-fired power generation. So very quickly, the traditional technologies, biomass, geothermal, hydro, low cost, provide flexibility to the system, but often limited by the available economic resource left to exploit. Solar and wind falling in cost. PV, utility scale PV has fallen in cost by 82% since 2010 to 2019. Concentrating solar power has actually fallen by almost a half, 47% in that period, but still remains on an LCOE basis at the top of the range. I would add that we use a conservative weighted average cost of capital here, which is increasingly needs to be revised, and we have some work to do that. So this will obviously vary if you have different rates of cost of capital. Onshore wind, very competitive now down at the bottom end, offshore wind coming that way as well. So, in some respects, we might think that CSP has not done quite as well as we would hope, but we know from auction and PPA data a little bit of a crystal ball into the future. And let's see, here we go. So what we've done here is the same approach, except in blue we have our LCOE database, which is based on total installed cost and capacity factor for individual projects. And we've overlaid that with an auction and PPA database, which we have, which is around 10,000 projects or programs now, and that's in orange. And when we look at there's a number of caveats. I suggest you read some of our reports to look at that, but the body of data provides us the direction of travel. And you can see for solar PV and onshore wind, we're scalloping in under the cheapest fossil fuel-fired power generation option for new capacity. And indeed, many of the projects now are undercutting even the marginal operating costs of particularly coal-fired plants. So there's probably 500 gigawatts of coal-fired plants we could retire today and replace economically with PV and onshore wind. But there's been a bit of a step change for both concentrating solar power and offshore wind, signaled or heralded in these auction and PPA results. It's quite dramatic for CSP because we've got a very thin market, not so much projects as we've talked about. We'd like to see more, but that's the situation we have. So going from around 18 cents LCOE down to PPA and auction results of say around 7 to 8 cents for the few that we do have firmed up. So a bit of a step change and falling well within the lower band of fossil fuel fired costs. So that's good news. Obviously this has benefits for customers and consumers, but obviously we're still looking at a little bit of a lag compared to fossil fuels. What happens specifically to concentrating solar power? And here we have a 3-panel chart of total installed cost, capacity factor, and levelized cost of electricity. Total installed costs fell as the market grew. So we had increased competition, competitive procurement, some economies of scale, some improvement in competition along the supply chain. But obviously we'd see more with greater penetration. Capacity factor increased, and we'll talk about that why just in a minute, but it has a lot to do with technology improvement and improvements in D&I. And of course, if you get those two, one going down, the other going up, the cost of electricity from CSP has fallen, as we said, to around by 47% between 2010 and 2019. All right. Okay, so what's been going on? So let's dive into these trends a little bit more detail. And one of the important ones has been the shift to better resource quality locations from about 2012. No disrespect to Spain, who led the deployment, but there are a lot of, as Jonathan showed in his chart, a lot of areas with great D&I, and that has been, we've seen that transfer through into higher capacity factors. The small but growing scale of projects has led to benefits in terms of more experienced project developers that can reduce margins, better understand project development processes, can squeeze supply chains, etc. At the same time, we have seen some improvement in the competitiveness of supply chains. Obviously, that would benefit greatly if we saw more growth. Particularly opportunity comes up, obviously, if China starts to deploy a lot more. The technology has improved. We've seen improvements in operating temperatures because of improvements of heat transfer fluid and reduction of losses across the system. Whole number of reasons that we don't have time to talk about right now. And of course, competitive procurement. So when the pressure is on, people have to be creative about reducing cost. So nothing new here compared to any of the other solar and wind technologies. What we've just seen is the deployment lagging. So we're at a higher point today in terms of the overall cost of electricity, but as we saw from the PPA results, coming down. So just to dwell a little bit on the fact that the capacity factor has increased. On the left-hand side, you can see the capacity factor of projects built between 2010 and 2019. What we saw is an increased capacity factor that's been driven by not only the shift to higher DNI, which you can see on the right-hand side, on the x-axis, the DNI, but also we've seen a shift through time, the darker blue projects on the right-hand side, to greater hours of storage. So our opinion today is that it's not economical to build CSP without significant amounts of storage, because that gives you the lowest LCOE in these high areas of DNI. Obviously, there's been some of these other technology improvements as well that have helped contribute to the higher capacity factor. But that gives you a graphic idea of what's been happening. Now, we've also looked at the future, and we have some work that we've done with DLR to basically define a set of technology baselines for solar towers and parabolic trough technologies, benchmark those costs across each of the G20 countries with adequate DNI, apply local cost adjusters, and come up with an idea of where we are today for these countries potentially new to CSP, and then did a bottom-up techno-economic analysis of the technology and cost reduction, technology improvements and cost reduction potentials for CSP out to 2030. Because just like for solar PV and onshore wind, we think the costs will continue to fall. And the result of this analysis, which will hopefully be published later this year, is that the install costs can continue to fall, perhaps by around 30 to 35% by 2030 on a central scenario. This will vary by country, obviously, depending on the local components, cost factors that we have, and also the resource quality obviously will affect the levelized cost of electricity. So here you can see what could potentially happen compared to our reference plant in 2018, 2019, and the LCOE in 2030 across the G20 countries. So falling potentially below 5 cents per kilowatt hour in say, Saudi Arabia with low cost civil engineering and excellent DNI resources. And all of this is, again, with a relatively conservative weighted average cost of capital of 7.5%. So if you could get below that, obviously costs would be even lower. So those are actually really quite competitive values when you're looking about competing with fossil fuels without paying for its externalities, is at a minimum, say, 5 cents per kilowatt hour. So this is actually a very promising outlook, and why we have confidence that we think this 300 gigawatts minimum by 2050 is going to be possible and economic. And just to put that in context, concentrating solar power, does it really have a cost challenge? And I think the answer is maybe not, but and I'll just explain why using this chart. So here what we've done is put together some results from PPA or auctions for solar plus storage. So the y-axis is the winning bids. Now there's some caveats to this because sometimes the bids are for 15 years, or the contracts, sorry, are for 15 years, not 25, the economic life of the asset. But you can see on the left-hand side, basically we've got, and on the x-axis, we have the storage duration hours. And basically what we have is a lot of utility scale projects with quite competitive values of around, and this is kind of the leading edge, right? Values around, say, $40 US per megawatt hour. But storage is clustered around, say, you know, half an hour to 2 hours with some larger projects. Up top, you can see that when you start to go to longer duration storage or remote locations, as we are in Hawaii, the costs rise quite significantly. And out on the right-hand side is CSP. In this case, I think it's good to be all alone by itself, because it really demonstrates that for long duration storage, there is not a solution at the moment, an economic solution in between those 4 hours and say 12 to 15 hours for CSP. And that's with the DEWA result for 7.3 cents per kilowatt hour. So by 2030, obviously we're talking about being lower than that. So does CSP face a cost challenge, or is it really not just being able to access the value that it's contributing to the system? And I'd like to hand back to Jonathan to talk a little bit more about that in detail.
Jonathan, could you take?
Thank you. Thank you very much, Michael. And just to interject a personal comment here, I find IRENA Michael's slides and IRENA in general to provide a master class in the two-dimensional visual representation of quantitative information. I really know how to tell a story graphically. So to the question of finding the value, bringing that value of CSP into the system, hybridization with PV and battery systems, as we're starting to see, does seem to present a very attractive way forward. In some of the work that we've done with Tunisia, and Belhassen may take this up a bit, the profile of many countries is to have both daytime and evening peaks. And when you have an evening peak, meeting that when you have a great deal of PV is a bit of a challenge. So in these typical projected profiles for Tunisia for 2025, 2035, we see significant peaks both in summer and in winter, from between 6 p.m. and 10 p.m., long past the time when the battery systems are going to be economic, as we saw in the previous Michael's previous slide. And it's here where certainly you can integrate PV and CSP on a system level, but then you're building trying to build a very capital intensive, very expensive plant, which can be quite challenging. So combining the two at the plant level, or at the very least in a solar park, could be provide a good way of balancing and optimizing all four of those technologies: the CSP, PV, thermal storage, and battery storage. In Morocco's phase one of the Midelt complex, where this sort of system was specified, a very respectable price of under 7 US cents per kilowatt hour was achieved. Here, the aim was to build a plant that met the demand curve in Morocco, at the same time reducing the LCOE. And the solution that was requested would combine both PV and CSP in a hybrid a solution whereby PV would be operating during the day, generating and providing electricity to the grid, and the CSP turbines would be operating mainly in the evening. A minimum of 5 hours storage was required, and the plant as a whole is required to provide 25% of its energy during those evening peak hours. In the eventual design, PV capacity is 1.2 times CSP gross capacity. With this, the systems thus specified, it starts to become competitive with coal. And as many of you know, Morocco is highly dependent on imported coal for power generation. So the overall cost is brought down compared to the CSP plants up at in the Ouarzazate site, in large part because PV is simply much less expensive per installed kilowatt. But there are other ways that the cost was reduced. The solar field for the CSP component was smaller than for a standalone plant, since the turbine would be run mainly at night. The PV component could be put to multiple uses, not simply providing power to the grid, but a portion of it would also provide power to auxiliaries, for instance, keeping the molten salts at appropriate temperature. In addition, the requirement for land was optimized by deploying PV panels around the heliostats. And of course, there are opportunities for putting a common infrastructure together. MEDEL 2 is being approached a little bit differently, where developers will are providing their own solutions for hybridizing or not CSP, PV, thermal, and battery storage. I mentioned before that there are significant opportunities to localize the supply chain, really important for our client countries. Some of it is on the upstream side and project development and in manufacturing components, but it's mainly in plant construction and of course in the O&M as well. The really interesting thing is that for a lot of countries, that already have a pretty strong industrial base, not just Morocco, but I'm thinking Egypt as well. Manufacturing of the components is much easier to do than for PV, where China is quite dominant, and we're talking about semiconductor industry, which is harder to start up. On the environmental side, the question is often raised about water consumption. In fact, CSP, as long as there's dry cooling for the power block, then there is the water consumption is not really significantly different from PV panels, which like the heliostats for CSP do require regular cleaning. So in terms of supporting investments, there are a wide variety of support options on the investment side, on the generation side that have been used everywhere CSP's been deployed. There have been grants and soft loans to subsidize investments, tax credits, loan guarantees as well. There have been quotas, the feed-in tariffs that you saw for the first set of projects in China, for instance, and in Spain, giving way more and more to competitive bidding, auctions, and even green certificates. The public, I've already mentioned that public financing has been important, including climate financing. But IPPs bring to the table not just private financing, but also the know-how of developers. If you have utilities that are specifying the technical characteristics of plants, then you are not taking advantage of the know-how, of the experience that, as Michael has shown, has been important in bringing down costs. It's not to say that there isn't an important role for the public sector. You can't get a good bid unless you have a well-characterized site, unless the issues concerning land with evacuation of power have been dealt with, and it's important to build up capacity, as Eric indicated at the beginning, for absorbing of handling, of having a TSO that can handle these new plants. So the technology neutral tenders really we see is the way of the future, and that allows for hybrid plants to come online. And as we move forward as the World Bank, that is the approach that we'll be recommending. But enough from us. I think it's important to hear the perspective from the Ministry of Energy in a country where the CSP is on the table, and where we're excited to see some developments in the coming years. Belen, back to you.
Thank you very much, Jonathan. Yeah, thank you very much, Michael and Jonathan, for this presentation. It was really comprehensive, and I think you're on the money with a lot of the trends and takeaways that you've been giving us. There is a lot of questions for you, so we'll get to them towards the end. Thank you very much also for taking off the screen now. Next, I'd like to ask from Mr. Shiboub. I think now is your turn, from one of the countries that are considering CSP, from Tunisia, to hear, what do you have in mind for CSP in the country? So go right ahead.
Thank you. First of all, I'll begin with the presentation of our strategy. During the last decade, the Tunisian energy landscape has been marked by a decline in primary energy resources and continued growth in demand. This resulted in a structural energy deficit, which reached 59% in 2019 against 7% in 2010. This situation poses a real problem of energy dependence, and therefore a significant risk of security of supply in the medium and long term. To face this alarming situation, Tunisia has been resolutely engaged in an energy transition policy aimed at setting up an efficient, diversified energy system, less dependent on fossil fuel, and meeting the requirements of the economic and social development of the country, while preserving the local and global environment by opting for sober and clean energy solutions. Tunisia has ratified the Paris Agreement with the commitment of NDC to reduce our carbon by 41% in 20 and 30. Indeed, Tunisia's energy strategy is based, among others, on the following strategic axes. The first one is to develop energy generation from power generation from renewable energy. 30% integration in 20 and 30 in electricity mix, and to reinforce the interconnection with the neighboring country and with Europe with ENMED project. Eric knows well this project. The second one is strengthening of energy efficiency, reducing primary energy consumption by 30% in 20 and 30. In order to achieve these objectives, a regulatory framework with private-public partnership specific to the development of renewable energy was put in place through the following power generation regime. We have 3 power generation regimes from renewable energy. The first one is the concession regime, a large-scale project. The second one is authorization regime, project no more than 10 megawatts for PV project and 30 megawatts for wind project. And the third one is self-consumption regime, autoproduction. Consumers who want to produce their own electricity benefits from the right of transmission and to sell surplus electricity produced exclusively to the state-owned utility. As you know, I will speak only for the concession regime. We have already a call tender for 500 megawatt PV project. We finish the negotiation with awarded the promoter, and the agreement are under the process of approval by the government and then by the parliament of Tunisia. And we hope this will be done in by March or April 2021. Then I would like to speak about the challenge of renewable energy integration. The main challenge for Tunisia is how to manage and integrate a huge capacity of intermittent renewable energy sources. In this context, the Tunisia government has joined the World Bank program, KEEP MENA CSP, in order to study the opportunities to develop CSP in Tunisia. 2 phases of technical assistance was carried out and completed. The first phase objective was to carry out prospective analysis of Tunisia electricity mix and to assess to what extent CSP technology could contribute to the development of an electricity system at lower cost and meeting national renewable objectives. The first phase shows the key role of the CSP in an optimal electricity mix by 20 and 35. Indeed, the CSP solar presents many advantages for Tunisia thanks to its storage system, which makes it dispatchable and capable of producing as well during the day and at night. To best meet the national demand for electricity. Following this first phase of technical assistance, the Tunisian government decided to move forward in its reflection by studying the various possible options to achieve its strategic orientations. This led to the launch of a second phase of technical assistance initiated in 2018, aimed at carrying out modeling and technical economic feasibility study and identifying the optimal site for the development of a first CSP project in Tunisia. So, given technological developments and market data, technical configurations for a controllable solar power plant consisting of a hybridization of CSP technology with PV technology and or battery storage are also studied in the context of this analysis. We identify a site, Bni Mhira, it's in the southeast of Tunisia. however, more in-depth investigation to determine the optimal technical, contractual, and financial characteristics, as you said, PPP project for the project are necessary to be able to launch a dispatchable solar project in Tunisia. What I want to say that now we saw that storage battery isn't already used to generate power. It's limited for the most project we see in like in Abu Dhabi in the Emirates. Projects with battery storage are used mainly for limitate or mitigate the fluctuation of power of capacity. But here, when we are speaking about CSP, we are speaking about storage of power and how to produce electricity, not only for 1 or 2 hours. We are speaking about 5 hours and more. So this is why we are now thinking how to implement CSP project after 20 and 25. And within Call of Thunder, we know now we choose a site, and we are trying to study how it will be the principle, the main contract for this project, and the optimal technical solution for this project. I would like finally to thank the World Bank team involved in realizing this program. And as I said, CSP, it's very difficult to compare CSP to battery storage. They didn't offer the same service. CSP technically is better, I think, than battery storage. If we are thinking how to implement projects from with storage from solar source, what offer now CSP flexibility of using of storage is, I think, better than battery. But we'll see. The study will demonstrate if it will be better or no. And the main challenge, as said Jonathan, for CSP is the cost of the electricity. Thank you, and we will hope we have our project from CSP by 20 and 25, 26. Thank you.
Thank you very much, Shibu. It was a really interesting presentation. I think you are going through what many other regulators in many other countries are going through. You know, they need to compare different technologies to see what they offer, you know, and to bring out some conclusions out of it. And it's not necessarily straightforward, but it's good that we are approaching this technology agnostic, you know, from that perspective of let's see, you know, what it can offer me, and then open up and see, you know, who can give you what the system needs, essentially. So thank you very much for that, for those remarks. Next, I'd like to ask Gonzalo for the final presentation. And, you know, there are a lot of questions for all of you. So we'll take those right after this presentation. Don't worry, there is time for it. So Gonzalo, when you're ready, we're now going to hear about what's happening in Spain with CSP.
Thank you, Belén. And thank you for the wonderful presentation that we have seen today from Michael and Jonathan. It has been quite shocking for us. I think it's a very good that we have a report on CSP. So now it's time to discuss a little bit about the Spanish case. And actually there was a question on the Q&A box about exactly this. And also Jonathan talked about this. PV with batteries is a product, and CSP with thermal storage is a different product. And each one has a different use. We can say that PV with batteries up to 2-3 hours are cheaper than CSP. Anything from 3-4 hours onwards, CSP plus storage, plus thermal storage is cheaper than PV with batteries. And this is aligned with CSP, let's say, DNA. CSP should be the base load for the night supply. CSP is not the tool for a very peak demand or a very short supply that we aim to be the base load of the system, mostly during the night. So actually there was another question on the Q&A and said, hey guys, PV is cheaper than CSP. Why are you still working on CSP? Every time I hear the question, PV is cheaper than CSP, I must say, only while the sun is shining. During the day, PV is cheaper than CSP. During the night, CSP is cheaper than PV with batteries. So going to the Spanish case, we do have, this is the Spanish fleet. As some of you mentioned before, Spain is still leading the worldwide installed capacity with 2.3 gigawatts. This represents roughly 2% of the total capacity system. And in summer, we supply between 8 up to 10% of the peak demand. There you got the entire breakdown of the different technologies of CSP. And a very important thing, maybe for the debate afterwards, in Spain, we will have CSP without storage. Because at that time, 2010, 2011, there wasn't any price signal for the storage, as we are seeing today. So we might discuss a little bit later if would it make any sense to add thermal storage into already existing plants. We can discuss later. But what about PV and CSP? PV, this is the actual real profile of PV in Spain for the last year, for 2020, for the entire year. And the question is, okay, while the sun is shining, PV is there. But what about before and after? And this is something I learned in Protermosolar from Luis Crespo. I think he's still connected on the webinar. It's like comparing coffee and beer. People from the US right now, when you are having your breakfast, you don't want a beer, regardless of the price. You don't really want a beer. Hopefully you don't want a beer at this time of the morning. The same as when you are watching football or soccer in the evening, you prefer a beer over a coffee, and you don't are that price sensitive because they are different products. PV and CSP are not competitors. They are complementary products. So, because they serve different needs to the system and at different hours. Also, we saw the Tunisia demand profile in the presentation. This is the expected demand profile for 2030 in Spain. All of you know about the DAX curve. I'm not going to waste too much time. We know that while in the mornings, the demand net of solar contribution will start decreasing very quickly, there is even a risk of curtailment at midday when the sun is very high and PV is generating at its maximum capacity. And in the evening, as the sunset comes, there is a strong demand for new generation and even a risk of load shedding. And this may happen as PV or renewables energy goes into the market. What is the solution? As you can imagine, CSP. This is my final slide, and here I want to be very, very systematic. What we're proposing is that we had CSP, and now we will have new CSP. This new CSP may work in the following way. During the day, and I'm going to put the DAX curve, during the day, we will just gather energy, not producing. We are not going to contribute to that curtailment. We will just gather energy. After the sunset, we will complement PV, just start dispatching our energy, and we will be providing energy all night long until the next morning. Here in blue, the solid line, it's a 12 hours storage CSP, and you've got also 15 and 9. This is just an example. This is not any specific case. This is just to show that PV and CSP must complement and work together. You were discussing earlier before about these hybrid plants. we could make a hybrid system into the Spanish system, just combining PV and CSP. And my final two comments, first one here in green, this year, 2021, we are expecting an auction of at least 200 megawatts of CSP. So after 8 years, we might see CSP once again in Spain. And the total plan of the government is to reach 5 gigawatts of CSP until 2030. Thank you very much.
Thank you very much, Gonzalo. It is good to see, you know, that CSP is back in the government's agenda, and I think we'll see, but it seems like potentially might increase even over time, you know, given how much PV and wind they want to put into the system, that, you know, in order to manage it, you need to be thinking about what happens. You know, if you want to achieve 100% renewables by 2050, then you need to rethink your system, so to speak. So thank you very much, all of the speakers. It'll be really great hearing you. Now we have, as promised, 20 minutes for questions, but really 20 minutes. So we have a bunch of questions that have already been sent in, and I think mainly Michael, but other speakers have also been doing a great job of answering some of those. So I see, Michael, you've been busy. You've been answering a lot of those. There are like a very, very specific things. So I just wanted to, there is a question that comes time and time again, and it's a question that I think we've answered many, many times during the presentation, but I think since it's been asked so many times, it's worth bringing it again in front of you and asking you to answer it specifically, which is, people have phrased it differently, but essentially it comes down to the same thing. PV keeps on going down, batteries keep on going down, you know, why is this? And I know we've answered it a number of times, but I thought since this asks so much, then we should approach it again. So perhaps each of you could give a sort of 1 minute thing on like the main reason why you think, you know, still there is the reason to consider it and maintain it, even if you think about the future, there's still going to be a room, or whether there is going to be room for CSP. So Michael, why don't I start with you, if you don't mind, and then we'll go around.
Yeah, sure. So, I mean, we've been, you know, we maybe have fallen into the trap a little bit of assuming that everyone understands what's, you know, we're talking about, the if you like, the building blocks of the reasons why we think CSP is important. I think you have to go back to the idea that the electricity system is a system. It has to meet demand in real time, more or less instantaneously. So you need a balance of assets to ensure that you're going to generate at that time that demand occurs, or you want to have in place demand side management to avoid those messy peaks. And today's electricity system has this, if you do a load duration curve relative to price, you see something that starts, you know, at a low value and comes up and then spikes up. There's a few hundred hours each year where it's really expensive to provide electricity in a fossil fuel system, right? So in today's electricity system, it requires a mix of assets that have higher costs than the average because we're meeting demand instantaneously. And so we come back to this issue of, yes, solar and wind are really, you know, actually ridiculously cheap now and getting cheaper. So we want to maximize the penetration of those. And as Gonzalo and Jonathan and Belhassan already mentioned, that means that you need to be able to smooth out the gaps where the sun, the PV isn't contributing quite enough, or the wind isn't contributing quite enough. And that's where CSP comes in. Don't focus necessarily don't focus necessarily on the cost, but on the value that CSP can bring, and it's in filling in those gaps that otherwise would be really expensive. The challenge that CSP has, in my opinion, is that most of its value today is in this longer duration storage, and the sad case that we face today is that most electricity systems haven't deployed enough solar and wind that longer duration storage is properly valued. So this is the challenge for CSP, is that unlocking a lot of the value is going to come further into the energy transition. The slower that happens, the slower we see the widespread deployment of CSP, and none of that's good.
Thank you very much, Michael. Good points made there, for sure. I mean, and some of the questions were, how do you compare with the PV plus storage? But the reality is already, when you have variable resource, you need extra payments in order to be able to give certain services that before were taken as, part of the system. So next, I don't know, Jonathan, how about you, since you were presenting with Michael?
Right. So valuing the services that that CSP and thermal energy storage bring is really important. That flexibility, right? So a lot of the focus on bringing greater variable renewables into systems now is focusing on flexibility. Where does that come from? How can it be brought in more cheaply? How can it be brought in a way that minimizes the reliance on fossil fuels? Mentioned, hydro reservoirs, pump storage. That's a great option for countries that have access to reservoirs, but not everywhere has it. So, really what you're looking at in many situations is replacing gas turbines, so open cycle gas turbines. So when you're bringing in CSP, you're not just it's not just a matter of looking at the cost of those kilowatt hours, but as Michael said, their value in terms of monetary value for the system, which is often implicit, it's not explicit. There aren't really markets for the kinds of storage that CSP, thermal energy storage systems, bring, but also the value in terms of the climate proofing your power systems and reducing reliance on fossil fuel imports.
A lot of points made there and all well noted. Jonathan, that's correct. Eric, would you like to add? I'm going for you too as well, Gonzalo and Belhassan, don't worry. But
yeah, I think, a lot of the technical answers have already been given, but I think, when looking at, I talked in my intro a bit about a toolbox. I mean, when we look at it from the World Bank perspective, we are really looking at technologies that can displace thermal power and ideally outcompete thermal power for the duration of the 24-hour load cycle, right? And I think that's really where CSP comes in. It's a great complement to PV, but it's also a great complement to other variables like wind, which is very unpredictable and shifts through, and also to peaker plants. And I think that as MENA that I work with directly start looking now at plant replacement, peaker plants, baseload plants, CSP and hybridization with CSP offers actually a kind of more of an apples to apples comparison for planners as they start shifting out old power plants. So I think that's the real benefit of these technologies over.
Thank you very much, Eric. Let's hear from Tunisia that hopefully, very soon we'll be celebrating that you guys are going to put a CSP plant there. But, what is your thinking? I mean, you've gone through this very recently, and you're still kind of crunching the numbers. So what is your message to the people that are asking the same?
I think when we develop PV projects since 2014, we see a decrease of the cost of the project, an exponential decrease of the cost. And I think now what we are searching is when it will be the perfect cost for the project. So when we are speaking about the perfect cost, we are speaking about how to change power generation from gas or combined cycle, thermal power generation with CSP. And we know now CSP, it begins to become competitive with gas or gas turbine or combined cycle. But we think that from 2025, decrease of the cost of CSP will give them the possibility to be better, less expensive than thermal plant. And the main, let's say, advantage from CSP that we have not only power generation, but also a credit of capacity. We can have a dispatchable capacity, not only for 1 or 2 hours, we can get it for more than 5 and 6 hours. And that's why now we are thinking how to get the perfect time for the implementation of the project with the best price.
Thank you very much, Ivo. And last, Gonzalo, you've heard this question a million times. So can you come up with anything different, I suppose, is the real question here.
Sure. I mean, it's not the same to generate 1 kWh at midday than at midnight. So we should start thinking who is going to provide electricity to the system in 2025, 2030 after the sunset. And one thing that people sometimes get wrong is that they compare LCOE with the cost of the system. LCOE is the cost of your technology from an isolated point of view. So your technology working, let's say PV has a LCOE very low, but doesn't care what is happening when you are not producing electricity. In order to do a proper planning, you shouldn't consider only LCOEs, because if you take only the lowest LCOEs, let's say we put in Spain only PV at night, we need to put fire just to cook or to see anything at night, because we won't have electricity. My point is that for the right balance of the mix, energy mix, we need to consider not only LCOEs, but which technology contributes to get down the total cost of the system. And as I was saying, you may have plenty of PV with batteries. That is not the cheapest cost to the system. And the question is, if not CSP, who is going to provide electricity at night if we really want to get rid of nuclear, coal, gas, and any other non-renewable technologies?
Well, thank you very much, all of you, for your answers. I think hopefully, you know, this is clear to the people who are here, but I know that this is the question that I get all the time. So I know that is something that, even though it seems obvious, it might not be obvious. Michael made a good point. You know, maybe, you know, we're taking into consideration that actually people understand when they don't necessarily. The next question I have is more about the future, and it's something that is also very trendy right now. It's about renewable hydrogen, or sometimes it's called clean or green hydrogen. And I'd like to understand, you know, there is a lot of move right now, a lot of talk about green hydrogen or renewable hydrogen. I want to understand, is this potentially competition because it's long-term storage for CSP? So could it be a part of an answer that is similar to CSP? Shorter term, could it be actually a vector of growth? Because, you know, CSP, like renewable hydrogen, may need power 24/7, or how do you see it, like in the scheme of things? And I'm not gonna say who should answer this question, but I know that Michael should for sure. And then I'll leave it to you guys to tell me, you know, who wants to pitch in, because I think these questions are going to become more apparent, you know, as time goes by. So go ahead, Michael.
Yeah, thank you, Belen. It's a really good question, and I think the first thing we should say before we talk about this is that you know, we're at a point now where we believe that hydrogen, renewable hydrogen, will play an important role in the energy transition, but the relative economics of it providing different applications in the energy transition is not so clear yet. So what we're talking about here is really what we think the outlook looks like today. That will change in a year and a couple of years, as it has done when we've talked about renewable power generation. I think there is, at least in the short to medium term, there's a relatively simple answer in that in countries with very high DNI, hydrogen is probably not going to be necessary for the power generation sector because we have CSP. And if you want to use low cost renewable solar PV and wind to generate hydrogen, the round trip efficiency starts to already push you into a zone where it's probably similar to the cost of CSP. So now, so in that respect, it probably is, going to be a complement in other areas of the energy transition. So where we have hard to decarbonize capacity. So for instance, in industrial processes of high temperature heat, so using hydrogen for the direct reduction of iron ore, potentially in cement making, and in chemicals. Now, so I don't think hydrogen is competing, if you like, with CSP in that respect. That hydrogen might provide some additional flexibility, potentially in absorbing surplus solar and PV, solar PV and onshore wind, I think is again complementary. So I don't think it's eating into the potential for CSP. With the current costs of CSP and the added value that we've just talked about, and in terms of providing the flexibility to the electricity system, it's there can be certain use cases where hydrogen may be produced, but I suspect it's not going to be the most economic route to utilize your CSP electricity. But hydrogen is definitely going to play an important role, particularly in the Sunbelt, where you will see CSP coming in, because there are lots of places in the world with great solar and wind resources which can get you that very low cost electricity, which means hydrogen can be competitive.
Is there any other comments from any of the speakers? Jonathan, Eric.
Okay, I mean, just quickly, I think the point here is that in a deep decarbonization, which we are heading to, we need all these technologies. Hydrogen is excellent for, driving, logistics. I mean, one of the interesting applications that popped up in the US now with Plug Power is, warehouse forklifts, which are run on fuel cells and hydrogen. I mean, I wouldn't have dreamt of that myself, but this is how the market responds. So these are not the same thing. We are not going to generate hydrogen with PV and then turn it back into electricity. It's too valuable. It will go into other sources, as was mentioned by the previous speaker. And I think that it's that's the real value. CSP, you can run around with a CSP plant to feed trucks, for instance, or boats on the sea, right? So all of these applications has an immense potential for hydrogen. Over.
And where there is a role for hydrogen in power systems, the first applications are likely to be small mobile or remote systems, not grids.
That's an interesting take, Jonathan. I just thought that it was a good question that they were asking here. So Shibub, oh, here you go. This is the man I wanted to answer, but I didn't want to really push you because I thought, go ahead. We cannot hear you. Oh.
We are speaking. You hear me now?
Now we can hear you, yes.
About two different steps of generation. There is the upstream and the downstream. Whereas we are speaking about renewable energy and CSP, we are speaking about upstream. What we are dealing with hydrogen is how to make our energy transition and how to use, let's say, hydrogen, which is sober and to decarbonize transport, driving, like say, ship, everything with hydrogen. So hydrogen is a solution for, let's say, storage, because we will get some excess of renewable energy, so we can produce hydrogen with renewable energy, but it isn't a solution to produce, like said Eric. We can't compare generation power from hydrogen to CSP. It makes no sense to compare it. We use hydrogen not to generate power, but to reach our target of energy transition and to get it for other uses. That's why we are speaking about two schemes: the upstream and the downstream. Hydrogen, it's for downstream; it isn't for upstream.
Thank you very much, Shibu. You know, what I'm interested in is whenever we see these hydrogen routes, they're all going through the power and X side, the power to X side. And in that power to X, you do need an 24/7 renewable energy in order to guarantee, you know, green. So in the end, you know, it all goes back, you know, for example, in Chile, you know, they're already considering CSP in a lot of the projects. So that's very, very interesting, I think. Okay, so thank you very much to all of you for that. Now, since we have just a few minutes left, I'd like to invite Eric and then Dolph to give us the closing remarks, please. Eric, and just before Eric starts, just to let you know that we will send you the recordings and the materials, and we know some of the questions haven't been answered, but most of them have, and we'll get in touch about those. Thank you very much. Go ahead, Eric.
Thank you. I'll be very brief. This has been a very exciting discussion, and I do hope for those that are not CSP insights that we have answered a lot of the questions around complementarities of solar technologies and the broader range of supply technologies that we need to support the entire demand profile of the 24 hours. And this is, I think, where CSP has a major role to play. We've also heard about the impressive gains in CSP that I think has been largely underreported compared to, you know, the headliners of solar auctions, etc. But, you know, hybrid power plants coming down to 7 cents or so, or even in Dubai, I think without hybridization, is very competitive for most countries if you compare unsubsidized new fossil fuel capacity. And I think that leads to the rather significant potential that IRENA mentioned of 300 gigawatt in the near future in high D&I areas. And I think that looking forward, what we see in MIDEL2 that was mentioned in Morocco, with technology neutral bids that really focused not what is being supplied, but really what is being served. So what kind of demand, what kind of time of day is being served in terms of the overall energy mix. This is where we're heading, and something the World Bank is highly encouraging. But it's very complex and will ask a lot of planners and utility folks that are doing this procurement process. And great to see the progress made in Tunisia with their large-scale solar PV program, but also the emerging thinking around storage, trade, and long-term planning, including the CSP plan for 2026, 2027. We're quite excited about that. Finally, just for other countries that do want to pursue CSP development or other dispatchable least cost renewable energy generation options, the World Bank is there to support the governments and the utilities in these countries, whether it's in the phase of planning and evaluation, together with our partners in IRENA and others, but also when it comes to investments. So we're looking forward to a very bright future for CSP, but also for renewable energy as a mainstay in the energy sector. Over to you, Belen.
Thank you very much, Eric, for those closing remarks and that optimism. I love always, you know, that kind of like can-do approach, and things are getting better. And Dolph, your closing remarks, please.
Well, as we've heard, significant cost reductions for CSP going forward. So that's going in the right direction. That opens up new perspectives. I think it was also clear from this discussion, you have to think about CSP from a power systems perspective. It's not directly competing with PV. It's a little bit different type of technology. And we have to look also a bit into innovations such as these hybrid systems, maybe also combinations with industrial heat supply, etc. So, and if you take that into account, there is a bright future for this technology.
Thank you very much, Dolf, and thank you very much all of the speakers. Thank you very much, Eric, Dolf, Jonathan, Michael, Mr. Chibub, and also Gonzalo for being here today and sharing with us about this report, about all of these new findings and work that you have done. Michael made a point, it's like this technology, is a long time coming, like it was providing value, renewable value before its time, if you like. And because, there was so much gas and so much base load in systems, there was no real need, like just for that was provided for renewable energy. But the time has come around, that cycle has ended. And now I think that people are starting to see that actually this is very much needed. And even though we haven't had flashy, like taglines in newspapers yet, I think that a lot of the work has been done in the background that is looking like, the market is starting to move faster and faster. I'm talking about, of course, situation in Spain, all of the work that has been done in Tunis and through the Middle East and the north of Africa, but also other countries that are like looking at, projects coming back. The countries like Chile, where plants are coming to an end. Even the US, is looking again at revisiting that because it's needed in the grid. So I think the time has come where we understand that it's not just, okay, how much energy do we need? Okay, we're going to generate that. We're not just responding to demand anymore. We have understood that the free solar resources that we had actually had a value. And we need to always think resource, in the one axis and generation in the other. And I think that mindset is changing. And therefore, CSP definitely has a role to play. I think this is what we heard today. So thank you very much for all of you. And thank you very much for the people in the audience. And see you next time, because there will definitely be a next time. Thank you.